All right, new chapter, section 10.3, slope-intercept form. Just real quick, this is going to be a recap from probably something you started to see in probably around 7th grade. If you have forgotten it, do not stress. We're going to go over it. You're just going to become very well acquainted and very quickly. So, let's look at points, okay, on a graph. Okay, don't be intimidated by these little things there. Okay, those are just subscripts. That just says like the point x1, y1. Those are just points, like the first one and the second one. So let P1 of x1, y1 and P2 of x2, y2 be 2 points on a line. All it's basically saying is you have a point here and a point here, and there's a line. Okay, the slope can be calculated as follows. Okay, this is going to be very important to remember. Okay, even if you don't remember anything else, okay, forget all this, remember this right here. Okay, slope equals m, okay, that's just a variable name, equals rise over run, and y2 minus y1, or x2 minus x1. It's basically taking this point here and subtracting it from this point here, from this point here. Okay, it's going to become very apparent. This is going to become second nature to you. You may also see this. I don't want to kind of go too fast, but in some books you may see it denoted like this. Okay, you will see it later on in your math career at this college like this. That is just a symbol that means change. Okay, so, and what is that? That right there is a change. The change in y over the change in x. So let's scroll down, take a few little notes here, because slope does denote something else. Okay, and you are more aware that you're dealing with this on your daily life than you think. So what else can slope mean? Slope also can stand for rate of change. Okay, so rate of change, a constant. Let's make it this way. Let's make sure we are very intentional with our wording. A constant rate of change. Well, what is rate of change? You're talking about slope, you're talking about rate of change. What do you mean? Well, let's look at some examples. Some examples of rates of change that you know about that you don't realize that actually fits into this definition of slope and slope-intercept form that you're living with on a daily basis. If you take a typing class, which I don't even think they do that anymore, maybe I just showed my age, but you would look at words per minute. Or if you're going to buy a car, how fast does it go? How fast does it go in miles per hour? But one thing that's big on everybody's mind right now is obviously cost per gallon. So the faster your car goes, the more it's going to cost per gallon. Now, how does that work out? Also, you know, if you look at the words per minute one, you can say, well, I type 50 pages in 2 minutes, or basically 25 pages per minute. And now using that, I can, using that definition right there, I could calculate, well, how many pages would I roughly type in 10 minutes? Well, now I know. Or 11.5, or whatever. So this is where slope-intercept form comes in. So will you ever use this? Yes. Why is it important? Because when you go to the store, you're gonna see things that, if you go to Albertsons especially, if you look on the little yellow tabs, it'll tell you, hey, this is the cost per ounce of something. That's a constant. As we fill this bag up full of whatever you're gonna buy, for me it would be like caramels, okay, we're going to charge you this much per ounce. Well, I can see one bag and it says it's going to cost me 65 cents per ounce. Maybe another one's going to cost me 73 cents per ounce, but it looks like it's cheaper. Okay, but I'm actually spending more money. So that's kind of where I'm kind of going with this a little bit. So let's do a little example here, and then we'll do a few. As we get into the hawks, you're going to understand it a little bit better. So let's remember our definition of slope equals m equals rise over run equals y2 minus y1 x2 minus x1. Well, let's look right here. Find the slope of the line that contains the points -1, 2, and 3, 5. Well, let's denote this one as x1 and x. Oh, I'm very sorry. That's b. That would be a y there. What is going on? Why is my eraser not wanting to erase today? There. And that would be y1. Okay. Well, right here, that's x2, y2. Hopefully that gives you a better example of subscripts. For some reason, whenever I saw subscripts early on in math, they just freaked me out. I was like, what do these mean? Why are they doing this? Well, you're probably way smarter than me. So now just plug it in. Okay, so let's be very intentional about how we plug things in. And by that, I'm going to show you, because there is one, I'm glad they have a negative in here. So we have y2 minus y1. We have 5 minus 2. Okay, remember, this is your formula. Don't ever change the formula. So you have x2, which is a 3, minus, okay, -1. You have to keep that -1. Okay, don't just suddenly go, okay, well, I've already got a minus sign there, I can just put 1 down. No, you have to make sure you go 3 minus parentheses -1. Okay, then we work this out. We get 5 minus 2 is 3. Well, 3 minus a -1 from your early school days, but also as a good review, when you have a negative and a negative, that turns into a positive. Okay, so you actually have 3 plus 1, and that is going to equal 4. So m, your slope, is going to be 3 over 4. So let's plot these. Let's show you what it's actually saying. Well, in fact, let's do it in a different color here. Let's do it in a bright blue. Let's go to -1. That'd be to the left and then up. So I have, that was not a good color actually to choose, was it? You can barely see that. Let's do pink. Okay, and then let's go to 3, 5. 1, 2, 3, and then go up 5. Okay, and I'm going to connect these as good as I possibly can there. Oh, that wasn't too shabby. All right, what is this slope saying? This slope is saying, when I go up, I'm going to rise. Remember, rise, and then run. Whenever you have a positive on both these, it's going to be up and to the right. Okay, so if I go up 3, so there's 1, 2, 3, then I can go to the right 4. 1, 2, 3, 4. And I can do that forever, consistently. It's going to be constant. This graph, this line, will always move at a step of 3, 4. And yes, I could move it backwards. Look, I could come over here and go, well, can I go back 1, 2, 3, 4? 1, 2, 3? Yeah, I sure can. And there would be another point there, and we could continue our line all the way down forever. That's just by turning that into a negative. So hopefully that gives you a little bit better understanding there. Let's kind of keep it going here. All right, just some few little things here. Let's switch this back over there. Okay, we have a graph right here. Here's your y, there's your x. If it's going to go positive, it's going to go in that direction. Depends upon steepness, okay? If it's negative, you're going to have another one here. It's going to go down. That would be negative. So let me change this back to my red. This would be positive. This would be negative. So we say all this to do what? We are getting to slope-intercept form, which is this right here. This is the meatloaf. This is what we're looking for. For any equation in any form, y equals mx plus b, the slope of the line is m. Okay? Definition, y equals mx plus b is called slope-intercept form for the equation of line where m is the slope and 0b is the y-intercept. Let's see why that is, and then we're just going to start digesting this whole thing. If you have a graph, on that graph, let's put some points in here. Okay, there's my y, there's my x, and I have a point, I have a line that comes straight through there. We're going to pretend that landed, and it landed right there. The reason they're saying this m is the slope and 0b is the y-intercept, look, 0b, this would be b right there. Because that's your y. It's on the 0, there's that. M, that's your slope. That's what we just learned to figure out. Okay? That little rate of change thing, that's what we were finding out for that. So if you know b and you know the slope, you can put this in slope-intercept form. Let's do an example real fast, and then we'll get into some hawks. Okay, find the slope and y-intercept of negative 2x plus 3y equals 6 and graph the line. Okay, notice this is not in the proper form. Okay, this is not in slope. Oops. Intercept. Oops. Just rewrite again because my we'll just put it that way, not in slope form. Guess my eraser doesn't want to work for me today. So we need to rewrite this in slope form. That is our goal. Okay, what is slope form? Let's remember our definition. It's y equals mx plus b, where that is the y-intercept. That is our slope. So 1. Let's rewrite. We've got negative 2x plus 3y equals 6. And I do urge you, rewrite these. Do these on paper, rewrite them. There is a connection from your hand to your brain and your brain to the paper that is very good to start getting used to now, because do remember you're going to be taking 3 assessments in this class, and those are going to be done on paper. So if you don't get used to writing these down and remembering your negatives, and just, it actually is kind of a small skill that people are getting too used to doing things on a computer. So first things first, let's get that x to the other side. Well, how are we going to do that? Well, let's add 2x. Oops. To both sides. Okay, when we do that, then this is going to reduce off on this side, and we're going to be left with 3y equals, well, I like the variables in front, it looks better, and we're getting into this form, remember, that is a positive 6, so plus 6. Well, we still get a 3 over here. Remember, we got 3 times variable y. Well, the inverse is going to be to divide it. And we divide it to everything. Okay? So that is going to reduce off there, leaving the y by itself. And when this is all said and done, we have y equals 2/3 x plus 2. Okay? Now remember, this 2 right here is our y-intercept, which basically means that its coordinate point is going to be 0, 2. This is our slope. So we can start from this point here, go up here and graph it. Let's find that really nice purple I liked earlier. So 0, 2 is going to be right here. Well, this is positive, okay, which means it's going to go up and to the right. So if we go up 2, 1, 2, And then we go to the right, 1, 2, 3. There's another point there. Then we can do it again, 1, 2, 1, 2, 3, and 1 there. And then we can come in here and we can graph our line, because we now know that this is our slope and that's our y-intercept. And we'll do more of these whenever we get into hawks. You'll see a lot more examples. So, all right, now it's your turn.